Hi, so hopefully this will be the last video and we should be able to finish the paper up here. So Nicola makes party hats for young children. The hats are in the shape of cones. Nicola's design is shown below. Nicola makes hats by folding pieces of card. They're in the shape of sectors of a circle. The hats are formed when the straight edges meet. So this is the cone part, this is the party hat in the shape of a cone, and then this is a bird's eye view of the piece of paper used to make that cone. So the piece of paper is a sector of a circle. So it's very important to note here that the hats are formed when the straight edges meet. So what this means is these two here are connected and then they form this circular base here, and then this is the vertex, the top of the cone. So from this bird's eye view, when you connect these, the observation you need to make here is that this length here, when you pull this around, is going to be the circumference of this circle, effectively. So circumference is equal to pi d, so circumference of the circle is equal to 15 pi. So this here is 15 pi, effectively. So from this, we can now work out this angle. So pi r, this would be 2 pi r times by theta over 360, and that's equal to arc length. So we have that 2 times pi times 20 times theta over 360 is equal to 15 pi. So immediately these pi's cancel. So 2 times 20 is 40. So 40 over 360 theta is equal to 15. So I know that 40 over 360 is 1/9. So theta over 9 equals 15. So therefore, timesing both sides by 9, I'll get theta is equal to, and then 15 times 9, so 15 times 10 would be 150, and then we lose a 15 for 9, so 135 that would be degrees. Okay, moving on. So Nicola also makes party hats for adults. Let me adjust my camera here. They are made from pieces of card that are sectors of a circle with radius 24 centimeters and sector angle 150 degrees. So Nicola cuts each sector from a circle from a sheet of rectangular card that measures 24 centimeters by 50 centimeters. Calculate the area of card that is wasted on each rectangular sheet. So the best thing to do here is draw a diagram. So it's also important to note that the radius of the circle is 24 and one of the sides is 50 centimeters. So the circle you're thinking about the 50 would have to be this way, is my point. So this being 24 and then this also being 24. So I'll draw it as another diagram because we're not interested in the full circle, right? But this kind of gives you an idea of what it would look like. So the actual thing we're cutting out is a sector of a circle. So what we're actually cutting out is something that looks like this. And we're told that it's 150 degrees and it has a radius of 24, and this being 50 by 24. So what we need to do is we're essentially asked for the wasted area. So this shaded area here is what we're looking for. And this is a standard area of sector problem. So hopefully this should be quite straightforward. And we can give out our answer in terms of pi, which makes it especially nice. So the area of the sheet, so area sub S, and that's going to be 50 times 24. So I would write this as 100 times 12. So I'm doubling this one and halving this one because it gives the same answer. So that's 1,200 centimeters squared. And then this sector here, so area of sector SC is going to be pi r squared. So 24 squared times pi times by 150 over 360. Right, so let's do 24 squared first of all. So I know that this is 576, but the reality is you will need a method of doing this. So let's do it formally. 24, 24. 0, 8, 1, 6, 0, 4, 0, 8, 6, 7, carry the 1, 5, 0. So this is 576 indeed. 576 pi, and then 150 over 360. So they both have a common factor of 30, but you can simplify it down any way you like, really. This becomes 5 over 9. So now we need to do 5/9 of 576 pi. So 576 pi divided by 9, so we're going to use the bus stop. So how many 9s in 5? None. How many 9s in 57? So we can get to 54 with 6 of them, with 3 left over. How many 9s in 36? That is 64. So this is 64 pi. And then we have to then times by 5. So we've divided by 9. Now we've got to times by 5. So 64 pi times by 5. Times in by 5 is easy. So times it by 10 for 640, and then half it. So it is 320 pi. And now, because it's giving your answer in terms of pi in its simplest form, this is really nice. So the area we're looking for, area wasted, area W, A sub W, is 1,200 minus 320 pi, and that is centimeters squared. Okay, last question. So a company makes steel solids, each have a mass of 1 kilogram. One of their solids is a square-based pyramid joined to a cuboid as shown below. The base edges of the pyramid are 5 by 5, so 5 here, 5 here. And the height is 4, so this is 4. And the density of steel used by the company is 8 grams per every centimeter cubed. So density, in effect, is how much weight there is for what the mass is for every 1 centimeter cubed. So density equals mass divided by volume here. So what this is saying is this density being 8 grams per cubic centimeter, it means for every cubic centimeter of the shape, it weighs 8 grams. So given that we know it's 1 kilogram overall, we can use this to find the volume. So firstly, this is 8 grams per centimeter cubed, so it'd be smart to write this as 1,000 grams, just for comparison purposes. The alternative is writing this as 0.008, but we don't want to do that. That seems needless. So let's sub in these values. So the density being 8, the mass being 1,000, and then over volume. So volume equals 1,000 divided by 8. So this is 125, and it's remember it's centimeters cubed. So again, if you can't do that divide, you need to use the bus stop. So the total volume is 125 centimeters cubed, and let's look at what the question's asking for. So calculate the vertical height of the pyramid. So it wants the height of this bit here. So what we need to do is find the height of this cuboid, the volume of this cuboid, and subtract it effectively. So volume of cuboid is going to be 5 times 5 times 4. So 5 times 5 is 25, times 4 is 100. So this is 100 centimeters cubed. So volume of pyramid is 125 minus 100, equaling 25 centimeters cubed. So now the volume of a pyramid is given by 1/3 the base area times the height. So we're going to sub in the values we have essentially. So the volume of the pyramid we've worked out to be 25, and that's equal to 1/3. And then the base is going to be square, which is 5 times 5. So it's 1/3, 25 times by the height. So from this, the 25s will actually cancel. So I'll get 1 equals 1/3 h, and then times in by 3, I get h equals 3, and that would be 3 centimeters. So my answer there is the height is 3 centimeters.